I'd like to take a quick temperature check of the audience. Who is running what you would call microservices in production today at your company? A lot of people. OK, good. Who is running more than 60 of them in parallel at your company today? OK, fewer. OK, there's some challenges still to overcome in getting up this road. And a lot of you didn't even raise your hand because you're not running them in production. Pay attention then, because as you make this journey, you're going to need this information pretty soon. The structure of our talk today, first I'm going to talk about this journey to cloud-native microservices and why it's a great place to make them resilient and make your developers focusing on the pieces you want them to. Jean from Blendle will talk about his experience of this and his team's experience going through exactly this story at Blendle. And then in the second half, after Jean, I will go into a bit more technical details about microservices on Kubernetes. I don't think that's my phone. OK, good. We are a little behind schedule, so we will speed up, accelerate through some pieces a bit. If we skip over some stuff that you really wish you knew, that you think is the most important part, sorry. We will be hanging out here at the end of the stage. Please come up and just ask us, hey, what about that? You skipped over that too fast. I didn't understand. We'd like to share. So from a background, I am a software developer by background. I spent a lot of years doing it. I love it. But the challenges can be hard. And these days, it's not really getting any easier to be a software developer. So in the old days, the good old days, we like to imagine them, this was all I had to worry about, right? I would write my code, I would compile it, I would ship it to the users, they would install it, they would call me with some annoying support questions sometimes, usually a PEBCAC error or something like that. And then we would write a new version, compile it, ship it to them again. That was it. That was simple. I could focus on this business problem that my product owner, we didn't call them that back then, that my business needed to solve or my customer needed to solve that would make us more money. And then things started to get a little more complicated. But it was still pretty simple, right? We had a client. That's a Palm Pilot, not an Android, so you know how old I am. We had a Java backend where we stuck everything, the authentication, inventory management rules, a logging library. It was probably just one server back then. Or one time it was my laptop because we couldn't deploy it into the server room, so we stuck my laptop into the data center with a note saying, don't unplug this, please. OK. So, it's not necessarily the good old days. There was a database managed by our DBA. She would really help us out with tuning the index and planning this stuff. But we were really, we had to all work together. And we thought a lot about software architecture, patterns, best practices. But it was still 3 monoliths that were tightly coupled together, which is actually, we still ship and compile them on all big chunks. But on a rollout, we have to coordinate with downtime. And we really actually had one scattered monolith, which we made lives a lot more harder for ourselves. Fast forward many, many years. A lot has happened. The next stage in that journey is this explosive growth of the internet, new technologies. World Press Photos was talking to you about the fact that times are changing. Companies need to move faster because the environment's faster. So we start decomposing our scattered monoliths into microservices that we can test and deploy individually and faster, keep functionality alive. That's microservices. We build up automation services for better deployments to keep these systems alive. And our modern applications start to look a little bit like this. Ooh, that's not 3-tier. That's a whole bunch of stuff. We got to separate it across zones so that if one whole zone dies, it stays alive. We keep serving to our users. But now that they're separated, we need to load balance between those machines, and we need to have coordination of state between them, so we have task queues and, health checks that need to be coordinated. And wow, it just got complicated. Because what I want as a developer to care about is this little piece, this red piece. My product owner wants me to build it. I need to build it to make money for my business or my customers. I want to knock a new feature out the door every week. But in order to do that, I have to understand all of this. In order for my application to live here, I've got to understand what's happening. I can't just write my Java code or write my Python code and trust it's going to go well. And not just me, and not just my teams, but each of the 20 other deployment teams running the 60 other microservices we have to have all have to have the same picture, use their head cycles understanding this, stay consistent about how they do it, otherwise you're in trouble. So, and pieces of this infrastructure start creeping into my code. How do I handle backoff requests? How do I configure, how do I find those services? Stuff that I shouldn't have to write into my code that makes it harder to operate my own code because of this infrastructure. My application shouldn't care that it's running in this. It should just run, and the environment should take care of it. So, and this is without even touching on these many other complicated parts of it that start creeping into my code. My team might be using a completely different tooling than another team because they evaluated their problem. They said, you know what? Go is the right thing for us to use. We need high streaming throughput. Another team says, you know what? .NET is the right thing for this. My team says, no, we love Python. There's no good reason for it. It's just religious reasons. That's what happens sometimes. But there's usually a good reason. So in the interest of time, I'm going to skip all over these. I think you all recognize these. What I really want to do is write some code to solve a business problem, to make it fun for me, because I like that. I like knocking a new feature out every week, to create a new business opportunity, to make money for my customers or whatever. So what happened, right? It's not the writing of the code that got hard. That's still fun, knocking out these problems every week. Running that code in production, keeping it alive with the requirements of the crazy modern times, is creating all sorts of complexity for our teams. So in the good old days, we'd write our code, we'd pass it to the QA team for testing, they'd send it back to us 5 times, we'd give it to the ops teams, and we're done. It's not my problem, they take care of it. Woo. In my company, in my old days we were pretty friendly, we knew each other, we liked each other, so we would refer to them as those poor bastards who had to handle the crap we gave them and handle all the out-of-memory errors and stuff like that. And they would call us those idiots who keep sending us this stuff. And we had a positive relationship, right? So you have silos, inefficiencies. It really boils down to cost and slowness. We all know what I'm talking about. Today, we've moved ahead many years. Nowadays, it's your problem. It's your team's problem. Remember, DevOps is not a title, or it shouldn't be just a title of someone on your team. It's a whole team culture. So the QA is now the problem of every person on the team. You're responsible for the code you ship, that the deployment works. If you're causing out-of-memory errors, someone's going to tell your team about it, and they fix it. This is the way it works. But you just want to focus on that application. So you're going to need a tooling to make this not your problem, or at least a solved problem. What would this look like in an ideal world for a development team and an ops team, a company trying to run all this together? You want every one of your developer teams to write what they want in a way that they can, in the language they want, and deploy it in the same way. Oh, there'll be more, don't worry. You want that app to just deploy. You just want to say, here's the application, the structure I want, make it so, and it's going to live in this environment. I don't want to have to worry about it. And hopefully you don't have to deal with the physical machines themselves, right? It's just you need a place for this application to run. This environment is going to give them the space to run that you don't have to stress out about. So what would such a solution look like in the modern cloud world? Well, we'd have container packaging for predictable deployment, dynamic scheduling to make sure that our application found a place to run, and recomputing that when necessary. And it's got to be microservices oriented, right? It's got to be something that supports this type of thing. Reusability of code, fast feature release, loose coupling. So let's start the journey. And wow, we're really short on time, unless this clock's a little started before I got on stage. We tried this journey on VMs. It didn't quite deliver. We never quite got the efficiency that we wanted. We never quite got the automation we wanted. It works, but it requires a lot of extra work. Just skipping ahead from that, why the modern developer world and the DevOps and the ops teams are falling in love with containers, right? We abstract away the operating system, the containers. Your application only needs to think about its interfaces with other applications in your environment. It doesn't need to think about all these load balancing things. They give our development teams a consistent way to package our applications and deliver them and dependencies, so my laptop doesn't end up in the data center again. It's a great solution to many of these problems. And if we only had one machine that never failed and never ran out of resources, we'd put them all on it, and life would be good, and we'd be done. But that's not the real world either. So we figured out Dockers are great, containers are great, but now we have a new set of challenges. Computers, everything you solve, there's a new challenge behind it. So once we've fallen in love with containers, We try to build a system with 50 services, microservices, built out of 500 running containers across 30 machines, and we discover that there's a new layer of complexity, how we do these things. Luckily, Google has some experience with this. We've been running containers in our data centers for 12 years, so we start about 2 billion containers a week. Gmail, search, maps, everything you touch at Google, you're touching a container. It's running on a container. The point of that is we have some experience at understanding how to structure containers in production and run them efficiently. So about 2.5 or 3 years ago, we launched this really cool open source project called Kubernetes. We took the lessons we'd learned, we packaged them up into an open source community. We gave it to the Linux Foundation, or the Cloud Native Computing Foundation, recruited community members like crazy, tons of people doing stuff on it, and basically we built Kubernetes to solve this problem. We wanted to expose the way we work to the world. We wanted people to be able to do this. It's a great orchestrator for your containers in production. You can run it anywhere, but when you run it at Google, a lot of things are automatically handled for you. Like the master, which is your control point. I don't have any architecture diagrams about that. It runs in, it's managed by Google, so you don't have to worry about it. Upgrades, nodes. You tell the master the way you want your application to look. It gives you the nodes to run on. If you need more or less, it takes care of that. It decides where to stick those applications. It routes traffic to them so outside users can find them and your internal services can find them. And it's responsible for setting it up and keeping it that way as life goes on and things break and things change. So I'm going to go into technical details in the second part. But first, I'm going to hand it over to Jean Mertz, the CTO of Blendle. His company has been on this journey for a while, and he's going to share his information about that experience moving into microservices, from monolith to microservices, and how Kubernetes helped them with that. So, Jean, come on up. Thanks for joining me.
Thanks, man.
I hand over.
Thank you. Morning, everyone. So I'm going to try to be as enthusiastic as Matt was just now, but those are some tough shoes to fill, so bear with me. So just quick question first. Who of you have heard of Blendle before? OK, quite some hands. For those of you who didn't raise your hand, let me just quickly introduce you to our product. So Blendle is an online kiosk that helps you find the journalism and background stories that are interesting to you. We present you the best stories you should read every morning and deliver them to you via email, the apps, native apps that we have, etc. There are no paywalls, no ads. It is you and great journalism. You either pay with a few cents per article, or last January we launched Blendle Premium, in which you pay a fixed fee every month, and we send you a selection of articles that are most interested to you. We also have a staff of editors who make sure that we try to burst your filter bubble every day again. Once you click on an article, you can read it, and we are very proud of the UI and the UX that we put a lot of time in. So this is the interface that you get when you read, and you can see it's all about you and the story. It's presented in the way that the author meant it to be read. So there are no ads, no annoying pop-ups. And we have a huge selection of newspapers and magazines you can pick from. You see Bloomberg Businessweek, Time Magazine. We also have New York Times, Economist, Mother Jones, Wall Street Journal, The New Yorker, etc., etc., etc. So there's always something interesting to you. If you want to check out more, go to blendle.com or download the apps in the App Store. But let's talk about why we're here. Let's talk about our technical stack. So we're currently got 32 employees, actually 32 engineers, working on our product. We are a polyglot development environment, which means we use Ruby for backend stuff, but we also use Python for the data scientists. We use Golang for where we need performance, and a lot of other languages. And this is something which we'll get into where containers really help. We've also got native apps and a website which is built with React. We started out with a monolith, but which startup doesn't? And we'll also get into that because it's important to realize that starting with a monolith is key to understanding how you're going to implement microservices. But in the past year, we've been slowly but surely splitting off microservices from that monolith. So let me give you some context. There are some numbers here about our production applications. The most interesting ones, we are generating more than 50 million personalized bundles every month. And we're sending more than 400,000 personalized newsletters in under 10 minutes to all of our customers. And this is really key when you look at microservices, because depending on the needs that you have for your small part of your application, you might decide to build your application in a specific way or with a specific language. If you need simplicity, you use a language that's easy to work with and easy to understand. If you need performance, you use C++ or Go or whatever. So it's key to understand your application and when to use what. So our journey brought us from the monolith on bare metal to microservices on a container-based cloud infrastructure. And there's more to come in the coming years, I'm sure of that. There is a big community around this, as we saw in the keynote earlier. So let's talk about that monolith. It used to be, and still is, a Ruby-based API with JavaScript frontend and native apps communicating with the API. And surrounding that API were lots of different object stores, databases, caches, proxies, et cetera, but they all revolved around that single API, and thus were dependent on that API always working. We did manual deployments using Capistrano. We ran our application on 3 machines, and they were running here in a data center in Amsterdam. And we had an operations engineer responsible for the production environment of our product. So there are obviously some pain points here that we wanted to solve. For example, these 3. Manual deployments, we can all agree, takes a lot of time, and it includes a higher potential of human error. So you need to get away with that. Running a single application on 3 machines also means that you're not using the full utilization of those machines, thus increasing the cost of running your application. And having development and production be managed by different teams automatically means that there is less accountability. Different people are responsible for different parts, different life cycle stages of your application. And that can complicate things a lot. But the other 2 could also be scratched off this list, because, like I said before, using a single API which has to be performant and easy, etc., is difficult. There is not one true language which can handle this all, or one true environment which can handle this all. So we moved to microservices. We've been doing this for some time now, and actually what we notice is that the technology problems aren't the problems that you should worry about. You have a lot of smart engineers at your company. They know how to solve this. But besides that, there are a lot of smart people working at Google, at Red Hat, at other companies. They put tons of hours, again, as we saw earlier in the keynote, put tons of hours in working on these projects like Kubernetes to help you solve those problems. In fact, it's about conceptual problems and processes that intertwine with your stack, your application. That's something outside people can't work on because it's your team who has to work on that. And that's what makes this interesting. For example, the biggest challenge we saw is that defining what part of your monolith you're going to split off into microservice is key. You don't just take a part like, this looks like a good block of content that we can take and put into a microservice. You have to think about the domain boundaries. If you don't do that, you'll actually end up right back where you started, but worse. You'll have a monolith split between microservices, which has to communicate over the networking layer to call different functions in different microservices. And we all know adding a networking layer increases the risk of hard-to-debug errors. So always go the extra mile, not to only make sure that you understand the different domains of your product, but also to prevent too much chatter and too much tight coupling between your services. And this is key to having a successful microservice-oriented architecture. If you don't, like I said, you will probably end up back where you were in the beginning. And Martin Fowler, who's a famous software architect and author. He works at ThoughtWorks, and he's also one of the original authors of the Manifesto for Agile Software Development. I think he said it best. He said, almost all the cases where I've heard of a system that was built as a microservice system from scratch, it has ended up in serious trouble. You need to have production experience with your domains in order to understand where it makes sense to split them off and where it doesn't. Or taken another way, he said, almost all the successful microservice stories have started with a monolith that got too big and was broken up. So this is very important. So how does Kubernetes fit into this picture? Like I said before, once you figure out how you want to split up your microservices, the technology isn't really the problem. Kubernetes will help you with that part. Of course, it takes time. Of course, there are challenges you have to overcome. But as far as we have seen, you can overcome them, and there is a big community around you to help you with that. I think Kubernetes turned out to be much more than a simple container scheduler for us. It was a way to empower our employees to experiment and self-manage. We actually saw an increase in teams and individuals deploying simple applications that they built, either at the end of the day or during a day where there was nothing else they were working on, or they built some cool project in the weekend. These things can then easily be deployed to your entire company and then be used by people. And that fosters innovation and increasing the speed of your deployment cycles. So these are some numbers about our Kubernetes cluster. We host our Kubernetes cluster on GKE, Google Container Engine. We have 8 nodes, of which 6 are preemptible VMs. And on those are running 575 pods, 134 services. And what's interesting about this is that because we use preemptible VMs, there will be a talk about this later today, I think, about what those are, in case you don't know what they are. But to quickly explain, a preemptible VM allows you to, it gives you a machine which can at any time be taken back by Google because they need the resources, but you get a fixed discount, a steep discount on these machines. And because we are running on Kubernetes and we are scaling up and we have multiple replicas per service running, it doesn't matter if a machine drops out, because the application will stay up. And what it does bring is a reduced cost, and it brings us automated Chaos Monkey-like infrastructure, where machines will fill all the time, and our engineers need to be wary of that and need to design their applications to be highly available. So what does Kubernetes mean for us in practice? All the services are highly available, like I said, and even the most simple ones we replicate at least 3 times, just because we want to make sure that it's always running, even if it's an internal application. And combined with microservices with clear defined domain boundaries, like I told about earlier, it means we haven't had a complete failure of our application within at least the last year and maybe more. Things do still break, of course. We're only human. But the impact of something breaking isn't as big as Blendle is down. It might be as big as search isn't working, or the email is delayed and is not on time to your customers, which is bad, and we need to fix that. But people can still use our product. And on top of that, we went from a couple of manual deployments every week to sometimes 50 releases per day. All our applications are automatically tested and automatically deployed. So let's take a quick look at some real-world use cases. For example, the Blendle button, which is a product that we built where, in this case, the Volkskrant can put it on their website, and people can buy the article for a few cents with the wallet they have at Blendle. And we shipped that in a couple of months, and we actually this was our first microservice that we built on top of Kubernetes. I think Kubernetes was still version 0.9 back then, so I would say don't try this at home, but eventually things worked out. Also, goals is an interesting use case because a product manager, lead product manager at our company, wanted a tool that could help us focus on our OKRs and on personal goals that all engineers at Blendle have. He built a quick tool, used Ruby on Rails, real simple, Bootstrap for the front end, and he deployed it on our cluster, and everyone is using it at our company right now. So it's really awesome. Something like this, where 2 engineers at Blendle build a spreadsheet which automatically queries the Kubernetes API, in which every team who deploys an application to Kubernetes adds a little bit of metadata to the deployment, where people can find support for this application. So adding a name, multiple names, adding a GitHub repo, adding an email address, stuff like that. And then it's automatically constantly updated in this spreadsheet for people to find out, for example, the support team, like, who can I ask about this problem? So these are some examples. Continuous deployment is another big one. We are actually running our own continuous deployment pipeline on top of Kubernetes. So we deploy to Kubernetes from a continuous deployment pipeline which is running on Kubernetes, and it auto-scales for whatever requirements we have at that moment. So if a lot of teams are deploying at that time, it just auto-scales. It adds more nodes, it adds more pods, and it's able to deploy in a couple of seconds, or for bigger projects in a couple of minutes. So to recap, I think starting with a monolith, or at least having a clear understanding on why you need microservices, is key. if you use Kubernetes, and in our example, Google Container Engine, the problem becomes less technical. You need to focus on the operational and conceptual parts of these problems. Teams become self-managed, they can release better, they can release more. You empower your teams. And as for us, you can release a new service in less than an hour. If someone has an ID, they build something, we have a continuous deployment pipeline, they can ship it. Thanks everyone for your time, and I'd like to give it back to Matt.
Thank you very much, sir. Hey, everyone. Thanks for letting me back on stage. I do need to keep moving fast, but I'll also try to keep up a little energy through this next part of the technical story. What is it about Kubernetes that makes it such a great place to run many, many microservices in a resilient way and empower your teams like this? Kubernetes has many powerful cases and features. They've been built over the last 2.5 years by the open source community and Google and other contributing partners working together, companies like yours, companies like Blendle. We launched it to the open source community with the intention of growing these use cases, because we know how Google used these things. We needed to know how you needed to use them, and the community has built up these use cases. Underneath all of these tools, all of these things that you wish you could do with your microservices, I would say it boils down to 4 key technical concepts. If you understand those 4 key technical concepts, you understand everything that's built on top of them in terms of how the system works and why it's good for microservices. So I'm going to explain pods, replica sets, services, and then labels, which is how they all find and talk to each other, through the eye of a microservice development team. Pods are the smallest deployable unit. Why not a container? Well, we know from our experience that they're at Google, hard-won experience, that sometimes you want to deploy multiple containers together. They will live and die together. They share the same cozy network space. They'll always deploy together on the same node. You don't tell Kubernetes to deploy a container. You tell it to deploy a pod. Now, often, a pod will be just one container, right? Your front-end team builds a Node.js thing. It doesn't need anything else. They put it in, they compile it in Docker, ship it to the registry. You establish your template that this is my pod. That'll get deployed on machines. Sometimes it's not even something you've built. You're using a third-party software, like Elasticsearch for your product search. Kubernetes has tools in there like to attach a volume to it, and the template says, get this Elasticsearch instance, get this volume that it's going to need, put 5 copies on it in different nodes, you're going to take care of it. It could also be other languages. So say your streaming team says, for high-performance stuff, we need Go. We also see something introduced here now, a second container in the same pod. We have this, I would call it a sidecar container. You could call it a helper container. Or maybe in old-fashioned language, you might call it cross-cutting concerns. Say you had something, you said, well, we need the SSL offloading to happen in a certain way. Let's have a team build a container around that. We put it in the same pod. Our Go team doesn't need to know what happens. A Go team just gets the message passed in. If without this, the Go team would have to think, all right, now in my application, I have to build this SSL offloading or this SSL piece into my application. Now it doesn't care. It just gets the information straight from the other pod. So these sidecar containers really help you separate out these cross-cutting concerns so you have less dependencies and your developers focus on just the piece they want. And then it gets much more complicated. You got your Java team with 10 years of experience, and they might also have a logging agent that they use that you want to separate from out of their code. Or even, for instance, you can put .NET Core in a container now, which means you can run it on Kubernetes. I've got a customer sitting right there that does that in production. WordPress Photos was on stage a few minutes ago. They do this in production. So it's a new world that we can do this stuff now. So on the microservices side, let's take the big red button that Blendle wants to deploy. What does that look like in Kubernetes world? The first thing we need to know, you understand pods. So the next thing to understand is the replica set. This is essentially just a control loop. You tell it, you declare the state you want it to be in. It's responsible for pulling that pod you want, throwing it on all of the nodes, doesn't matter which ones, making sure that they're running. So it's going to do these health check loops. If a pod dies, which is going to happen, things go wrong, you have an out-of-memory error, a node crashes, The replica set, nobody gets alerted, nobody gets woken up in the middle of the night. The replica set just notices that and says, oh, let me start another one somewhere else, and fixes it. It's basically like the Star Trek, make it so. So the replica set will create the state you want, and then keep the state you want as things go wrong in your environment and things change. The other side of that microservice angle is the service. People need to reach it. Your outside audience needs to reach it, or you're doing some internal services. A service is a logical grouping of pods that all have the same function based on this label selector. So it's using this label looking for front end. Oh, there's a bug on my slide. It's looking for back end, but it really it's finding the front end one. So that's a user bug, not the. Incoming requests are going to be load balanced across all of the pods that match. This means your service gets a stable virtual IP, its own port, and it's even its own DNS name, which you can use for service discovery and routing inside. So all of that is handled for you by Kubernetes. You put these two things together, you have your microservice, right? The replica set and the service combine to make your microservice. The replica set's taking care of the resilience. The service is handling the service discovery and routing. And now, bam, you've got people hitting your big red button. People deploy it on their sites. Traffic's going to hit it. There's always going to be here. Kubernetes is going to take care of that for you. Your application developers didn't need to think about all this stuff. But that's not the end of it. We don't just create. We need to change. Big red button goes live. It needs a lot of traffic. How do we scale it up as we add more publishers? Well, this still leverages the same core concepts. We just tell the replica set, give me 4 instead of 3, or 10 instead of 3. And the replica set makes it so. Bam, bam, bam. Now you've got 10 instances. The service just keeps finding them. Oh, I got to fix that back-end, front-end thing. Sorry. But we can't always predict what our scaling needs are, right? Blendel's selling this. They onboard a new publisher with millions of visitors. They don't know how fast it's going to take off. Or maybe they get a sudden burst. Maybe an existing publisher with multiple properties has tested it out on here, and then one day says, great, let's launch it on all of New York Times, and just puts it boom. Suddenly, bam, 10 times the visitors that they didn't even tell you about, right? Because you're selling it to them as a software as a service. You're saying, we're going to manage this for you, and you just do whatever you want. And so they do. They surprise you. Oh, yeah, bam. Oh, we didn't tell you we were going to launch to 10 million new visitors? Sorry. You want it to be able to scale. This also uses these same core concepts. Every pod is reporting its metrics to a central metric system in Kubernetes. Internally, it's Heapster. And you define the auto-scaling rule in Kubernetes for your application. Again, your application developers don't know about this. They don't care. Setting a target. A CPU is a common target. There's other ones that you can use. Say, if it's above 50% average, give me more pods until it's around that. And then when it drops below, mark this pod that it doesn't get any new traffic. When it's done serving traffic, kill it. Save resources. I want to use those for other things. So this is all built into these core. It's all built on top of these core concepts that we talked about in Kubernetes. Other things you want to do with this microservice. You need to do canary deployments, or you want to deploy a new big red button. You want to deploy the big blue button, or the big green button, or the round red button, or you just want it to behave differently, probably. User interface you can handle. There's a lot of strategies for this. Rolling upgrades, blue-green deployments, even just A/B testing. You want to keep them both alive for a while. They all use essentially the same technique built on these core concepts. You have your replica set with your service. Your replica set says, this is all version 1. You add a new replica set with version 2, but a different label on it but the same label. The service just finds it and groups it in together, so you're actually running these in parallel. And you can do a rolling upgrade with this way where you add one and remove one. It's an automatic tooling for that. Or you can keep them both alive and measure for a week. There's a lot of different ways to do it, but that's how you do it. You've just, for free, well, not for free, for a tiny bit of attention from your engineering or your planning team, you have all of these things in Kubernetes. Breaking it down, what does your single microservice look like in the Kubernetes cluster? The replica set is where you just specify how many you want, of how many copies of your application. The replica set reaches out to your registry where all your compiled packaged containers are. Says, I need these 4 containers or whatever you've defined. And it finds home for them on the nodes. You don't care which nodes they land on, and puts them out there. You define your service endpoint, and now you're routing traffic. Your microservice is live. A couple of little things. In fact, we've even boiled it down to one command called deployments, but you can still do it the old-fashioned way with these individual pieces if you like. That's it. That was taking a picture? That's done? OK. So that's what your single microservice looks like. But you're a big company. You're running 134 microservices together. You don't just have a single microservice. Your team might think about one, but everybody's got to think about it. It's going to look more like this. You're still scheduling it across all those nodes. You've defined your microservice by replica set and front end. And it could be all this stuff. You know, your Go team is happy, your Node.js team is happy. You're not arguing about dependencies and having religious wars about what language to use. And you can run all these things together. There's another thing you probably want to do as you're doing long-term life cycle of these microservices. There's that logging agent as an example. That's a cross-cutting concern. We got it out of our code. Our developers don't think about it anymore. They just write to log or whatever, and the logging agent picks it up from all of them and sends it to our shared repository. Blendle did this a couple weeks ago. They've got a separate team running this logging agent. So, oh, it's time to make a change. We need to update that. Could be a small change, could be a big one. In the old world, you'd got to go to all of those 60 teams and ask them, it's time to update your logging agent. Please update this library in Java. Please update this thing. And if you're lucky, 20 of the teams have time on their backlog to do it this week, and you get done. And 20 of the teams are in high priority. We're in crunch mode. We're launching something. We'll get to it next quarter. And 20 of the teams say, screw you guys. We like our own logging tools. We're not going to change. And so you end up in this really consistency across this environment of these types of things becomes hard. So you just went to microservices, like, oh, yeah, this is going to be great. And now suddenly you have a consistency problem. So in the Kubernetes landscape, how this supports your microservices is they just say, well, look, the team responsible for that logging agent just says, we're going to update that container in our registry. We are going to define new pod templates for every team that has the new logging agent. And just easily, with just a couple of little automation like that, they've swiped out the old logging agent and replaced it with their new logging agent. And they didn't have to take up the head cycles, the time of any of those application developer teams. Those teams could focus on what they're supposed to do, the next product, the next feature. So that is, I think, the story of why Kubernetes is a great place for your resilient microservices. New stuff coming out, because we're short on time, we won't talk so much about it. I'll give a link to it. The new stuff coming out is Istio, a service mesh. What's a service mesh? Imagine you had to build HTTP retries and rate limiting encryption, injecting SSL certificates. You're a big enterprise. You're a bank or something. You need consistency across all of these things. You can't just rely on these cowboy developers. And anyway, you don't want those application developers to be thinking about that. You want them just to live there. So you need this consistency across your whole landscape. In the same model that we had with the logging containers, you basically, Istio solves this problem in a consistent way across your whole space by injecting it into Kubernetes. Istio will run anywhere, right? It's a partnership of IBM and Google teaming up. Wow, it's the future. And Lyft, this crazy, taxi startup, who supplied this great level 7 load balancer. So kind of they teamed up, like 17 years of experience running services, input from hundreds of enterprises from Google and IBM, and this amazing L7 load balancer from Lyft provide this environment. Essentially, you will be able to run it anywhere. They've launched it in an open source method, same way that we have from Kubernetes 2.5, 3 years ago. I can see the same momentum building up. So today, it's for the bleeding edge people. 6 months from now, you're going to want to run it in your own data center. It's going to be amazing. If you want to get started, I found a really nice little getting started around istio.io docs tasks. So you like the ideas in general? You want to kind of get started on it? This is where I think you start. G.co/codelab/cloud has some really nice container engine deployments, which in 2 hours you'll deploy your own test microservice. Hell, 2 hours later you can deploy your own microservice using the same techniques. We've also got CodeLab booths out there to the back. Say you're a .NET developer, and you say, I want to try this magic. There's a whole series taking a .NET core from deploy simply to containerizing it to putting it into Kubernetes. There's the test thing. Also, out back, training. If your company says, we want to do this, but we need training, a bunch of the partners out there provide training. Or if you say, we want to do this, but we need a jumpstart. We need someone to help us get moving. There's also partners out there that are really, really good at helping teach your teams to do this so you can do it yourselves. And I guess that's it. Exactly on time. Or no, I'm 20 seconds over. Thanks, everyone.